And hello. Welcome to the second part of today's stream. I'm gonna mess around with the newly created model thingy. Our models, we added Spaceman to our model database. I'm pretty sure I'll delete some of it eventually. But let's see. We also need to create the texture. Let's see. Let me copy the texture into our asset folder. So now it's in here. There we go. And let's, well, cancel. Drag it over here, and we know it needs to be flipped vertically. And I think everything is fine here. Spaceman, texture, okay. So in our textures, we have the Spaceman. Whoops, I need to redo that. Let's see, Spaceman, let's delete that. And save it as a DDS. And we're back. Okay, so let's do Spaceman here. And let's see if we actually get our model loaded correctly. We do, but we have some problem overall. Let's see, maybe we don't need offsets since its pivot is around the origin. Doesn't seem like it. And let's do 15% scale for now. That's way better. But seems like our tiles are not getting loaded anymore. Huh. Or at least not drawn. So why is that? Let's see. Let's revert this back. Yeah, we do render everything the correct way there. So if I do Spaceman, why doesn't it work? Oh, maybe I have a buffer overflow. Yeah, that's why. We reshape the buffers. Okay. Okay, that's a nice error to realize. Okay, so so when we load the mesh, we create the mesh, we create the resource. Hello. As a hobby, a couple of years. I have no estimate in terms of in terms of if I were doing it full time. Okay. Thank you. That's nice of you. Let's see, we don't need this offset anymore. Next, we want to load our texture for this guy. And set our proper material. Let me just think for a sec. Yeah, okay, let's try out and see if we need to make adjustments to our texture loading. Let's see, core renderer, load texture, textures, spaceman.dds. This might not work since we haven't tested it with multiple textures. So far, no problem. And we don't have a problem with our previous texture, so that's great. Let's see what we end up uploading. Let's see. Spaceman, view contents, and it's actually correct. So, seems like what we created in previous episodes is just simply working. Let's just check the MIPS. Okay. Okay, that's awesome. I didn't expect that to work just straight out of the box, but it does. Okay, so now we have multiple textures. Now we have a model that is supposed to have a specific texture. So yeah, whenever we submit our models for rendering, we of course need to not on the debug one, on the mesh buffer here, renderable mesh. We want a specifier in terms of the texture. Yeah, these could be 32, I think. Not that it matters. Okay. And let's do 0 for the, oh, not for the player, but for the tiles. And let's do this. Maybe no, just 0. It's fine. And then we submit and draw, and we pass along the material into a packet here. Let's do unsigned int texture. And that's before the drawable, the texture. Here we go. And then we upload our draw data. Let's see, so we need to pass along the texture for this particular object. I'm pretty sure our shaders will have something like a common library for this. Yes, okay. But we are not using the object data here. Let's put it in here. Texture index. Okay, so should be fine. Yeah, I don't think it's a problem, is it? Well, we'll see. Okay, let's close the input layer rendering types. Close all of this stuff. Okay. And let's do temp data. Oh, of course I need to add this as well. Texture index, draw packet, texture. And we upload that. For some reason, redefinition. Huh? How come is it a... Which one? Polyps. Okay. Ah, right here. Let's see, shadow mapping does the same. Okay. Pixel shader, and this is for our polygon pipeline. And let's see, object data, texture index. And we see our texture is actually loaded for our model here. Okay, next thing, we need to specify some of the well, the material is not great, so so we need to fix that. Let's start by actually naming our materials here. Base, whitish material, that's fine. Gray material, let's do player material. We don't want much roughness, but we do want a bit. We do want a bit of Fresnel, I think. Yeah, okay. So our Player data struct here will, let's do unsigned int material, unsigned int, texture index. Material index, and let's set this to our and texture. There we go. Great stuff. I think we still need to work on the scaling. Yeah. Okay. I think this is, let's see, quite all right. Let's see. Let's increase the Fresnel and reduce the roughness. Just whoops. Let me. I gotta get used to these new camera controls. Okay, I think this looks fine. Maybe even increase this to just Well, if the light is too bright, we end up in a situation where the details get kind of like washed out. But I guess all right. Yeah, so the lights kind of like overrule the shadows. And I guess that's all right. Maybe if we decrease the ambient light here. Okay. So that's it for this part. I guess, let's see, if I set the lights to fairly high. Yeah, it's a very shiny, I think, which is good. Okay. Next, we're gonna do some rotation stuff. Let's see. Layer data. Quaternion. They don't have a type for it, it's just as a XM vector, I guess. Orientation. Initialize it as a unit quaternion. And inside our simulation here, do we actually have implemented? Yeah, we have all the F keys. We have WASD. We have EC. Let's do Q and R. Q, R. Let's do like this. Instead, Q, R, 7. Oh. I forgot to update this. Okay. 26, 26, and 27, 27. There we go. And then we can do some if core input layer is key down, Q. Let's do some math here. DirectX math, XM, quaternion, rotation, axis. Rotation normal. What does it return? Nothing. Okay. Let's see. Let's rotate around the y-axis. Oh, let's do normal here. Isn't that the one? Okay, it's not. Axis norm is that one? No. XM quaternion rotation normal? I thought I did. Okay. I might have not. And this is a register. It takes and then maybe 10 times delta time. Let's just do that. And then we set our game state, player data orientation equals the orientation times this, I think. If I can, okay. Okay, I need to use a method then. XM vector here. I think we're gonna use using DirectX. So we don't need to preface all of that. Okay, XM vector rotation. Okay, let's do XM quaternion multiply and rotation. I think this should be it, right? For us to rotate it. Let's just do a print. Oh, I haven't included the common helpers. Core common helpers. There we go. Try to rotate stuff. Let's do XM matrix, rotation, quaternion. Should be the one that spits back here. Yeah, okay. So, we need our renderer to support rotation of objects. So our mesh buffer here should have a XM vector of orientation, which is going to be like this. And let's just test that this standard value here doesn't rotate anything. So inside our renderer, there we go. When we submit our data, we do XM matrix rotation, XM matrix rotation quaternion, and we take our, oh, this is on the debug one. Okay. Let's do drawable orientation. And let's do SRT. And let's see, things shouldn't change, but okay, so I need to add the what do you call it, orientation here. So mesh buffer, renderable mesh. It's the third component, so this one will just get the game state, player data, orientation. Did I? Oh, haha, not here. Yeah. And I think a register can be initialized by just calling this, right? No, XM vector. Requires. Let's see. Does it want both? It does. Okay. XM vector. Okay, our mesh is here. Huh. Did I just rotate it? So most of the stuff worked. Yeah, except the player model that is now messed up. Let's see, quaternion. No rotation. Default. Yeah. Yeah. Should be fine. But are we in trouble in terms of setting the player orientation should also be like that. So why are we in trouble? Why are we in trouble? I mean, the texture definitely flipped. Let me try swapping the... Maybe the texture got flipped when we added rotation. We can test it by setting the model to... I guess... Huh. Now that is weird. Let's try debugging it. Let's do mesh buffer. Game state, mesh buffer. The last one. Orientation is fine. Mesh material, blah, blah, blah. Am I supposed to change the order here? No, shouldn't be. Shouldn't be, but let's just try it. Shouldn't be forced to do that, but who knows? We do have a model that is upside down now. We have a model that does get created, but um, on the opposite side of the level. Uh, so, well, whoops. Yeah, so that's definitely not it. And also we saw that our tiles were correct. Could it be? Huh. Let's just set the pixel shader texture here. Force it to be 0. Temporarily. For some reason, the model, is it below everything? Okay, yeah, so it's just flipped. That's why. So somehow our quaternion flips flips the whole model. I don't know why. I don't know why it would do that. I mean, uh, okay, let's try swapping the orientation here. So let's flip it around the x-axis, I guess. And let's do this. Can I do it on a temporary quaternion normalize? Can I do it? XM vector 4 normalize. Yeah. I can actually do it on a temporary, it seems. I'm not sure though. Okay, that's definitely not the rotation axis. Maybe this one. Oh, wait a minute. Now he just appears splatted out on the ground. Maybe I was right. I just didn't proc it. Nope. Oh, let's do 2 times 3.14. I think it's in radians. No, it's not. Well, no. Okay. Is it 4? 6? 8? Not entirely yet. 10. Oh yeah, that's the angle, of course. Let's do. I think, isn't it? Okay, that's 1/4. Then it's 4 times this. Can't remember most of my quaternion math. Let's see. Okay, that's way too much. Maybe it's just 2? No. Maybe a half? Uh, Quaternion, rotate around x-axis 90 degrees. Convert degree to radian. Okay, let's do a conversion then. 180 degrees times pi divided by 180. What? Doesn't work. um, what do you do down here, buddy? You all messed up? Okay, let's do this. And then XM quaternion. Multiply these two quaternions. Was key pressed. Okay, let's just do it once. We end up back in this same spot. And the x-axis is this direction, right? Okay. Okay, let's move it around the c-axis. Ah, there we go. Or what? Buddy, you be falling all over, buddy. Okay. For some reason, this is so stupid. It doesn't work. Okay, let's see if we initialize our orientation. Well, let me just try rotation from a matrix quaternion rotation. Let's do a. I want to see what this is. So the rotation here, the first register is 1, 1, 0, 0, 0. Okay, it flips the Y for some reason. Why does it flip it? What about the negative? Still flips the let's see, rotation here. 1, negative, negative, 1. Let's see. DirectX math, quaternion. Um, C and Y axis inverted. XM matrix. rotation quaternion. Axis inverted. XM quaternion. Oh, I see. I see. I see. It's because DirectX Math does it in a different way than I'm used to. The W component is the scalar. So this is a unrotated, what do you call it? Quaternion. There we go. We back. Nothing is rotated. Yeah, well, it was as easy as a look up into the library. Great stuff. Okay, we can then start messing around with the quaternion stuff here. And let's do rotation here. We rotate around the Y just for testing here. And actually, okay, I can't hold it down right now. Let's just do that, and let's just increase the amount so it gets more obvious. Okay, that's way too fast. But at least it works. Okay. He's dancing. Dancing, dancing, dancing. Let's do 5. Let's do R. Wait a minute. -5, of course. We haven't implemented R or what? We did. Well, right now it's not doing anything. Let's see if we ever end up here test. Well, for some reason, now it works. Huh? Huh? Oh, it's because I'm pushing the wrong button. I actually want it to be E. Do I implement E? I think so. Yeah. Oh. Okay. We need some kind of algorithm here uh, where we kind of like devise the or rather lerp between different orientations. So this should give us or rather slowly rotate our model towards the direction. So kind of like if we were moving this way, I would expect the character to kind of like face that direction. So DirectX math. Quaternion, rotate, vector. Okay. So we want to take our current orientation, which is forward. Let's do something like an xm vector here, direction, x, xm vector, direction y, and equals no direction y. Let's do okay, and let's keep it on the three-dimensional space here. So it's not this, it's actually C. Let's see. what actually happens if I hold down both buttons. Nothing happens. Okay. Oh, this is negative. Yeah, sure. XM vector move direction equals XM vector add direction C plus direction X. Let's just do that. We have a move direction. DirectX math, lerp, quaternion, slurp. Let's see. Normal vector, length. Let's see, I'm just looking through the math functions in DirectX math. Mm, Okay, we don't need that. Okay, so it seems like we could calculate the angle. Change orientation, quaternion in direction of vector. Okay, so it seems like Hmm. Let's try building a uh, so um, let's see. Okay, XM matrix rotation. Yeah, I'm pretty sure the function here. Yeah. Uh, let's see, XM matrix rotation. Can I get a quaternion? Uh, from a matrix. Okay. XM matrix. View. What's the function called? Doesn't really matter. Look at Okay, let's do move direction. Let's do a R here. XM vector rotation equals XM quaternion. Rotation matrix. And let's do okay, let's try this. If I hold down W and R. Okay. Now that looks funny, right? I mean, let's just do a bool flag here. False, true, just for testing. If okay, we definitely do some rotations whenever we move. But oh, wait a minute, did I not? Oh, I didn't set it back. Let me just swap the texture. Here we go. All right. Yeah, so we end up rotating this son of a gun too much. Okay, but I might have the idea how to fix it. XM quaternion lerp. Slurp. Maybe like this. Uh, 2.0 times delta time. Oh my lord. No, that looks better. It's still not correct. At least our dude turns around a bit, depending on which way I move him. It's not correct yet, but I guess we're getting there. Let's try flipping these. These are correct. Singular, no, not the up and down. Oh my lord, would you look at that? Would you look at that? Oh my lord. And we can give him a bit faster of a turn. Great stuff. So we need to figure out since we can devise our looking direction. Um, A is making us. Oh, I guess we could flip this, and then it would be opposite, right? Yeah. So it would follow our thingy here. Still not, but we're getting. No, and then this needs to be flipped. Oh, eh. Anyway, I really like that. I really like that. What happens if we do this every frame? Okay, we end up in a bad state. Bad state. Yeah, so for now, we have an error somewhere. Mismatch. The root signature. Oh. It only happens some of the time, I guess. I don't know why that bug came. Huh? Okay, what happens? Oh yeah, we still have the problem of rendering the sphere whenever this is disabled. Okay. But great stuff. Yeah, and maybe we can update some of this stuff here. I definitely should. Um, oh, whoops. Oh, I just can't stop playing around with this. Oh my god, this is so awesome. Yeah, come to think of it, I think his butt is too small. Okay. I think, okay, the way to rewrite this should be rewritten. Camera should be a archball camera that just gets computed from the center of the player and uh, uh, some offset and then a radius direction. Yeah, so because we end up kind of like computing the whole thing twice. Um, yeah, we compute the camera stuff and the player stuff, and we could just get the camera from our player. I mean, this is basically a view matrix where you have the position, which is the eye position, Yeah, so basically we could just do it. Okay, so the player data here. Model Y center. And let's store that model Y center. And let's not +3. Oh, I mean, this is. Okay, let's redo the camera function then. Let's redo the camera function. So let's open the header. Let's do a camera that is DirectX XM float free looking at DirectX XM float offset. Let's see. Yeah. Maybe we can't create a constructor. Because we will calculate the rest. Right now I call the. I don't use the other one, I think. I'm pretty sure I don't use this one. Or rather, this one. Do I? Just 0, yeah. Yeah, I'm not done. That's why it's whining. We do have a position, but I'm unsure whether we actually want to use it. This is fine. Okay. The M position. Let's do XM vector. Look at load float 3, right? Source. Can I do like this? Nah, I can't. Now it's fine for some reason. Yeah, we haven't created one yet. Okay, so XM vector off. XM vector position, maybe just position equals look at plus the offset. Let's do okay, so we can get the up vector. Let's see. Or what? Let's see if we're looking in a particular direction. Uh, 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 uh. Okay, maybe we need a up vector here. Let's do void update view matrix look at make some store load 4 times 4 a view matrix xm matrix look at right hand and position, and we will use the forward here and then the up. Okay. And let's create. Let's call it. No, I can't do that. Okay. Let's do create arch ball camera. Let's do a copying of looking at offset and then up. And that should be fine. Let's do something else then. Create archbolt camera, looking at XM float 3, XM float 3, and then up XM float 3. Let's see, 0, 3, maybe 2, and then player data X, model Y center, and then the set. Let's try that. Let's see what happens. Okay. Oh, wait a minute. In our simulation, update this. Okay. We're not far off here. Yeah. Let's see, and let's remove this. And let's do a arch ball camera, and let's do void set focal point xm float 3, maybe just const float x, const float y, const float c. Let's remove all this old stuff here. Forward is the one that we are maybe just forward equals x, y, z, 0. And let's do game state. Player, donor, camera, set focal point. Model Y center, and then C. Okay, so this is way more efficient. And we could do something else to this camera here. Add to position. And let's do a XM vector reference scaled pos. And position plus a scale position. Okay. Move direction, and let's do 2.5 times delta time. Let's see. It doesn't? What? Uh, oh, Yeah, it doesn't really work. Okay, maybe we want to. Yeah, but what do we want our camera to do actually? Set focal point. Well, we don't probably need to do that. Okay, we can actually store the camera offset. Um, special case constructor that creates a camera that stores a looking at point into the forward slot, the offset into the right vector, and the up into the up. It computes its position through that. It uses the special update view. And let's see, right, right offset. Special case, store the offset in here so it could always be retrieved. Maybe just offset here. Okay, let's do a special function then. Void calculate new position. Arch update position. DirectX XM vector. No, let's do from focal. Let's not add these right now. X, Y, C, 0. for plus right. We stored our offset in the right variable. Let's do there we go. Also, we can raise our camera quite a bit and then move it backwards. And this is the up vector. Great stuff. And I even think that we want even more of an angle. Okay. Should we fix that stupid shadow map thingy? Also, inside our renderer here, let's do a panel to control our light direction. Let's do so. Yeah. Let's do direction. Main light, direction. Okay, and let's do okay, and we need to update our shadow map stuff here as well. And then I'll do a break. Uh, oh yeah, I hate it. Create resource doesn't need to be done. Shadow map specifics. Okay. Let's move some of this stuff here. Okay. I think this is it. Light data. Shadow map data. Okay. Let's see. Transient flame for flame data. Let's see. Main light. Let's do a okay. Camera, main light, shadow map. Let's just do maybe seed center, DirectX, X and float here. Scene center. Let's do a float, shadow map, radius. Are there any other things that we need to port? So we update our I mean the directional light and color gets updated. And we upload the view projection matrix for it. We need to recalculate that. Yeah. We have an identity matrix here for the shadow map that gets initialized like that. Let's see. So look at it takes an position of the light, a focus, and a up direction. So um, we can access this by stepping into the temp data for the past data. Yep. So, oh, whoops. So our direction is available right here, but it's stored as a float. Yeah, it doesn't matter. Okay. We will load it into the register. Okay, so let's start out by doing this. -1 times XM load float 3 direction here. Let's see. Times frame data. Scene radius. Shadow map radius rather. And yeah, let's just do that. Oh, it's yeah. Let's see. I can't remember. And we store the last component to be 0, which is fine. Okay. So we use our new parameters here to load our what do you call it? Load our or calculate our light position. And we want our frame data the scene center. There we go. And then we calculate the view and projection matrix. And eventually I'll need to recalculate these values here. Needs an update to the near and far plane of the projection matrix. And we don't need to do this. We have our temp data. Now it's just with the lowercase d, and we don't need this, and we don't need to do this anymore. Okay. Our shadow map will probably look weird. Does it even get drawn? I don't think so. No, it doesn't get drawn right now. So we introduced some problem. Maybe, oh, yeah, I think our radius is 0, right? Yeah. So if we just set our uh, our frame data here, scene radius, or rather shadow map radius here. Hopefully we'll get a shadow map. Yeah, we do. We get a shadow map. And if we change the direction of the lights, our shadow here will follow. Yeah, we definitely do have some aliasing, but that's just the way it goes. What about at the edges? Yeah. Yeah, I mean, it shouldn't be, is it? Yeah, it's fine. The problem is that our shadow map is not moving, uh, which I guess it should. So if we run this in RenderDoc, and let's just move the character out here and then capture a frame. If we do our shadow map buffer here, let's see. Well, first of all, it's too far away from our scene to really register anything. And maybe we will get the problems I was thinking about when we do this. Oh, that turned off or handled a lot of the worst aliasing. I guess the shadow map was just being rendered too far away. Anyway, now let's do it out here. Let's see, shadow map buffer. As you can see, it's looking at the origin, so it starts having trouble recognizing this. So what we would want to implement is a shadow map where the center of the scene is moving accordingly. We could do this on construction. So that we could play around with it. Play around with it. ImGUI, slider, float, shadow map, map radius, float equals frame data, shadow map, radius, radius. Radius. Zero and then up to maybe 20. Yeah, it won't matter too much, I think, but now we can play around with that parameter. Okay, it does matter depending on the position of the shadow map. As you can see, it moves progressively closer to the origin, and the yeah, right now it should uh, have the opposite function. Let's see if we can fix that. So is it pipeline or is it root signature, shadow map sampler? Is it that one? No. Where is it? I can't remember. Border. What's the parameter? It's somewhere in the sampler description. Border color. Let's do white for testing here. So outside the shadow map, we don't want to cast shadows. Yeah. So that's fixed that problem. I guess we could do the same thing for the let's see, frame data. Oh, wait a minute. There we go. Scene center X, Y, and Z. Shadow map. scene center. Let's just call it scene center. Points 10, 10. Okay. So we can experiment with our shadow map here. Does it? If we, yeah. So if we decrease the radius, but move the scene off to the right, as you can see, we start getting shadows. But the problem is that the, what do you call it? The shadow map is not correctly offset, um, because we need to do one thing inside the renderer here. So to the light position, we actually want to add our scene center to it. Light position equals light position plus the scene center. And this should keep our shadow map straight. So we zoom in. Right here, we start losing our shadow map. Oh, well, it's not working. Yeah, this doesn't change the angle of the shadow anymore. It just changes the box of the shadow map, how much it's rendering. So that's exactly what we wanted. And we can change our light direction here. Great stuff. He's looking at his own shadow. All right, my guys. Let's see, maybe I could do something else here. So ImGUI label text. Let's do and then let's just do how do I mm, let's see. I mean, I don't like the way that the controls are like rendered here, but I guess it's just can I do something like begin? I can do ImGUI width. Push item width. Oh, whoops. Let's do just 20. Okay. Yeah, that looks better, right? That looks way better. Okay, let's do ImGUI text main light, and then do shadow map settings. Main light, shadow map settings, and let's see. Light. Uh, shadow map. Okay, let's move it back then. Okay. We're done. Get her done. Okay, let's do a sort of snapshot here. Okay. We could actually close these. Okay. Let me just save that. So, to recap, today I started out by modeling this dude here. Then after I spent like 4 hours doing that, I imported it, the model, using our simplified API. So it's simply just a call like this to load the OBJ model. And then I exported the texture, and then it's a simple call to load the texture. Then everything just seemed to be working right out of the box. So the backend implementation of the uploading of what do you call it? The backend implementation of the texture uploader just worked perfectly, at least for now. So yeah, but we discovered a bug. Let's see, known bugs. Known bugs at the moment. When the overflow gets triggered on the vertex/index buffers, we lose our original data. And only write the new data. To fix, make sure we copy the data from the old buffer into the new. Okay, we already started doing that. We did that actually by accident. Okay, let's see. So project Dr. Man's rebirth to do. No, let's just yeah, programming to do. And let's move this out of the application loop here and simply add it up here. So in application CPP, I'll have that readily available. So let's see. Let's see, what did we manage history yesterday? Miro. Okay, so we actually did the archball camera implementation. Oh, let's not delete it. Let's just mark it green because it's green and move it off. That way we can see what we're doing. Player controls, that's also done. Right now we have, as you can see here, player controls where the player orients to the direction that we're moving. I think that's pretty neat. Okay. We of course don't have any animation system yet, but we'll get there. Okay. And yeah, so so that's it, maybe we want to add a sticky here, archball camera, developer rotation mode. Let's make that readable. Yeah, we want to do that. So, for instance, I want to be able to rotate around this point here by right-clicking. It should be fairly easy since we can calculate the, yeah, maybe we should just try doing it and see if it's as easy as I hope. Anyway, that's what we want to do. Next, I want to be, let's do some, this is just, let's do something like player status bars. We want something like, whoops, that's pretty big. Special stat, and we want a health. Okay. And then I want some basic mechanics, basic interaction, let's do some basic objects, world objects. Whoops. Crafting, perhaps. Okay, let's do node. What's this? Okay. Let's do a, can I do a sort of, can I do something like a shape? What's, okay. What's this? So this is what? Okay. I'm gonna play around with this shape. What's that? Some kind of progress bar? I guess. Text. Posted. Thingy. Okay. Set date. Okay. 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 I'll figure that out later. Anyway. I just wanted to do a shape. And let's do a highlighted texture perhaps. Can I do that? Done stuff. Can I align it? Can I not? Oh, there. Neat. Let's see. To do. I might have deleted some notes anyway. I'm getting distracted here. So let's look into that function I talked about where we wanted to be able to rotate the camera. Um, I mean, in order to avoid doing this over and over, so we could do this by so our camera has 3 components looking at center of the object for focus slash player. Okay, and then we have a position and we have an offset. Distance from the player to the camera, the actual position. So this is easy to get from the looking at an offset, but maybe we wanted to kind of like rotate the whole offset, maybe. Let's try doing that. Void arch rotate offset y and then const float amount. And let's do XM matrix here. Rotation equals XM matrix rotation y, because we're rotating around the y-axis with this amount. And then let's update the right vector. XM vector rotate. Nah, okay, but we will do vector 3 rotate quaternion. Okay, we will just transform coordinate system. I think only uses the rotation part of the matrix, which should be fine since we don't have any translation in it. Let me just look that up. I'm unsure. Transform. Transform. Let's try it. Vector right and the rotation. Yeah. Let's try doing that then. Let's see. So let's try doing that. Yeah. So it basically works. Q. That was as simple as that. But it definitely gets confusing that the controls doesn't change when you're in that mode. The controls doesn't make sense. Right now I'm pressing the S key and we're moving down on the grid, but yeah. Yeah, but this is not supposed to be something that we use anyway, I think. I don't know. Maybe we'll definitely experiment with what seems to be good in terms of camera stuff. We could also add zoom by just scrolling. But yeah, basically we can rotate. Sorry if you get seasick. Specific camera controls currently for debugging. Update the archball camera around the player. Okay, so that's pretty quick. It's actually already done. Boom. Yeah. So in total, I've been streaming about 6 hours today. yeah, and I know that some people tuned in here, but I'm gonna do a break. Uh, um, yeah, I'm gonna go do some stuff. So yeah, I'm gonna end the stream here. Let me see. Someone sent me a friend request. Sure. Uh, and yeah, if you found any of this content helpful, inspirational, or just entertaining, feel free to support the channel by commenting, liking, or subscribing, and even checking out the other ways of supporting the channel in the description. There's a Discord server where people hang out and code game-related stuff. Some of the channels seem to have a lot of activity, and people seem to be collaborating, so that's pretty great. Yeah, I'll be continuing on this project here most likely tomorrow, maybe even tonight. But yeah, I'll have to see. Um, yeah, it would probably be fun to do more today, but yeah, I'll see how my schedule turns out. Anyway, that's it for now. Please take care, everyone, and yeah, keep on trucking.